It's really wonderful to be here. I'm sorry I can't be with you in person. So this is my my son Otto. This is a picture of him when he was roughly 2.5. He's reading Anil Seth's book, or at least pretending to read it. And it's, if you look at his behavior, the range of things he can do, the range of responses he's got at that age, it's hard to deny that he's conscious in at least a basic sense. He may not have what Dan Dennett called a kind of Joycean inner monologue. He may not have a lot of inner speech. He may not have a lot of explicit theory of mind. But a lot of people would just take it for granted, and I think fair enough, that he's conscious. Certainly his mother would have things to say if I suggested that he wasn't conscious at this age. Here he is a bit younger. I think this was taken when he was about 10 or 11 months old. Sophisticated behavior, not quite at the level of that which he produced when he was 2.5, but again, you've got a basic responsiveness to features of the environment. Not much language production, but a lot of language comprehension at this age. And again, I think most of us would be inclined to ascribe consciousness to Otto at this age. Here he is an hour after birth, and you might begin to wonder at this point, okay, are we so sure that we're dealing with a conscious organism? And here he is at 19 weeks gestation, giving us a high five. And here I think it's really unclear whether there's consciousness at all. And certainly the default assumption amongst most people would be that consciousness is not present at this point. So at some point, consciousness emerges, and one of the questions for the science of consciousness, with obvious ethical public policy implications, is when do human beings first become conscious? Maybe there's a window. What can we say about the parameters of that window? There's another question which is equally interesting, which is the character question. What are the first states of human consciousness like? I mean, what is it like to be a neonate, if neonates are indeed conscious? What might it be like to be, say, a 35-week old fetus, if indeed the fetus is conscious at 35 weeks? I'm going to focus mostly today on the emergence question, but if time permits, I've got a few things to say about ways of addressing the character question right at the end as a kind of a postscript. I should say this is a new project for me. This is the first time I've given this material any kind of public airing, so that's just a packaging. I'm not quite sure how this is going to go across. I think in thinking about infant consciousness, it's useful to pull back a little bit. As philosophers, we've got the luxury of being able to pull back and think about the emergence and character question from a wider perspective as instances of more general questions about the distribution of consciousness. So there's questions about when consciousness is retained or regained in the context of disorders of consciousness. And I'll talk about them in a little bit more detail shortly. There's obviously questions about animal consciousness. What's the distribution of consciousness in the biological world? And increasingly, we are facing and going to be faced with questions about synthetic forms of consciousness. So here are some neural organoids, about 4 millimeters in size, roughly 2 million neurons, twice the number of neurons in a bee brain. And, I think just about a month ago, the first scientific paper with the word sentience in the title was published about not neural organoids per se, but assembloids, systems that combined organoids with external devices. But we're getting to the point where people are raising serious questions about whether neural organoids, cerebral organoids, as they're also known, might be conscious, and how would we tell, right? So another instance of the distribution question. And of course, most of us are familiar, I guess, with people worrying about AI being conscious. I'm not going to talk about that, but again, there's this wider question, and I think it's useful to think about some of the challenges posed by infant consciousness in dialogue with some of these wider questions about our capacity to identify consciousness in different types of systems. Okay, so my topic, the focus today is this emergence question: when do human beings first become conscious? One place to start in thinking about this is with our folk psychological judgments. And I've put "our" in scare quotes here because it's not at all clear who we're talking about. And obviously there's cross-cultural questions, there's historical questions. It's just a really interesting question. What do different people at different times and different cultures, what do people assumed about when consciousness first emerges? I'm not going to do the business on that question, but I just want to point to a little bit of data that one might, it's a starting point for a discussion about the folk psychology of infant consciousness. For now, I'm going to bracket questions about what we should do with that information. I mean, what weight should we give our pre-theoretical judgments? Some people might think we give them a lot of weight. Some people might say, well, we shouldn't give much weight at all to our pre-theoretical judgments. I think that's a super, super important question. Let's just bracket that for now. So what are our pre-theoretical judgments? So here's a paper that came out about a year ago, I think. A questionnaire based on people who had gone to the ASSC, which is the Association for the Scientific Study of Consciousness, which is sort of the main consciousness conference that's held annually. And the respondents, they had about 160, 170 respondents from 2 years of conference attendees. And they gave folks a whole bunch of questions about different things. And here's their entities question: indicate whether you think each of the following entities has consciousness. So most people, so here though, definitely yes is a green, probably yes, light green, neutral gray, and probably not, definitely not, orange and red. Most people thought they were conscious. I guess there's a few people who are kind of doubtful that there is such a thing as consciousness, perhaps. Or maybe they're worried that they're zombies. Most people think that other people are conscious. Monkeys generally get a definitely yes or probably yes, but there's a few probably nots in there. Dogs, octopuses, and babies come somewhere between octopuses and bats. It's not clear how old the babies are that people are thinking that they're responding to. I mean, are people answering questions about neonates or 6 months or 9 months? Those are, I think, importantly different questions. But you can see that most people are leaning towards a yes or probably yes, but there's a significant minority that are neutral or probably not. And I talked to one at one of these conferences, one very influential consciousness researcher who I won't name, who was definitely not. His view was definitely no consciousness until about 2. Another interesting data point in thinking about folk psychological attitudes is work on, or attitudes to, infant pain. So there's a fascinating review paper here from a few years back looking at attitudes people have had in the medical world to infant pain. And they start with an absolutely harrowing vignette of a child who was given open heart surgery after premature birth without anesthetic, without analgesics, in 1985. So some of you weren't born in 1985, but I was around. It's not that long ago. And the mother, when she discovered the conditions, was a leading campaigner for the medical world to treat the possibility of infant pain much more seriously. The anesthesiologist said it had never been demonstrated that premature babies can feel pain. And that seemed to be not an unusual attitude in the 80s, not just in the US. I've talked to French researchers who said it was absolutely standard in France not to give pain relief to infants, even into the 80s. Another survey, I think this is from 88, and although this is 60 anesthesiologists, pediatric anesthesiologists in the UK, most of them thought that by 1 to 3 months, infants can feel pain, but there was a significant doubt. And even the yeses often said, well, I'm really not sure. Significant doubt for newborns and neonates. So there's, if you're interested in this topic, I heartily recommend the Rodkey and Riddell paper. It's but it doesn't make for easy bedtime reading. So how much weight should we give to our folk psychological judgments? There's a long conversation to be had here, but I just want to make one point, which is we do give significant weight to our folk psychological judgments in parallel domains. So here is the disorders of consciousness taxonomy. So these are patients who have suffered from serious traumatic brain damage. They've come out of a coma. They might be in what's called vegetative state or the unresponsive wakefulness syndrome. If they're slightly more aroused and slightly more responsive to their environment, they might be judged by neurologists to be in a minimally conscious state, or more responsive, they might be taxonomized, treated as though they're in what's called an emerged or minimally conscious state. So those are the basic categories that neurologists work with in this domain. And here's how they scale, here's how they score patients in the standard clinical response, which is the coma recovery scale. And I'm not going to go through this, but all of these behavioral measures, I think, are just souped up versions of pre-theoretical indicators of consciousness. They're things like being able to use objects in appropriate ways, being able to track objects as they move in front of you, visual pursuit, being able to respond to commands. There's nothing particularly, as it were, post-theoretical or scientific about these measures. They're absolutely standard. They're used not just for the clinical assessment of patients, but also in scientific research on this. And I would say they're not very far removed from ordinary pre-theoretical measures. So if one has a blanket attitude of not wanting to trust pre-theoretical measures of consciousness, one's certainly going to have to engage with our attitudes, not just to infancy, but to disorders of consciousness. So I'll just leave it at there. I'll move on. But even if you think folk psychological judgments are ought to be given some weight, you'd certainly want to move beyond them. For one thing, very young children, neonates, newborns, and fetuses don't respond, don't exhibit any of the pre-theoretical markers of consciousness, and one might want to know about the possibility of consciousness in those conditions. So how might we move beyond theoretical judgments? I mean, we want to move beyond theoretical judgments, pre-theoretical judgments rather, folk psychological judgments in the disorders of consciousness world as well. So how might we do that both in disorders of consciousness and in infancy? So one proposal, which I think is probably the default, is the one expressed here by Giulio Tononi and Christoph Koch in their paper here. In order to answer questions about the distribution of consciousness, we need not only more data, but we also need a theory of consciousness, one that says what experience is and what type of physical systems can have it. So the claim here, as I understand it, is theory-based approaches will allow us to move beyond our folk psychological judgments, and pretty much that's the only approach that will allow us to move. So we really need to take a theory-focused approach. I want to consider a couple of objections to the idea that we need to focus on theory in addressing these distribution problems. Here's the first objection. To require a theory before addressing the distribution problem is basically to put the cart before the horse. You can't, in order to develop a comprehensive theory of consciousness, you've got to know its distribution. A theory's got to be responsive to what things have consciousness, what things don't. And so you've got to fix on that before you can start to really build your theory. This is quite a commonly voiced objection in the animal consciousness literature. One of Michael Tye's recent books, he explicitly rejects a theory-based approach on precisely these grounds. Now, there's one response to that objection, which is actually the one I think Tononi and Christoph Koch would make, which is that there's ways of justifying a theory of consciousness that are as it were top down. So IIT, the account of the theory of consciousness that Stoney and Koch like, argues that a theory of consciousness can be justified on the basis of what they call phenomenological axioms. So what's a phenomenological axiom? It's a term of art amongst the advocates of IIT. It's a claim about the structure of consciousness that's apparently meant to be introspectively accessible and is meant to be self-evidently true of all conscious systems. So one of the axioms that they give is that consciousness is unified, and they go on to give a certain gloss as to what that means. And they take it to be evident, just from the first person perspective, that consciousness necessarily has a certain kind of structure, a certain kind of unity. And from that, they argue you can, they don't quite use this word, but I think it's a fair gloss on what they say, that you can deduce a theory of the mechanisms of the underlying nature of consciousness and its relationship to the physical world. And from that, you could go on to give an account of the distribution question, answer to the distribution question. I don't think this is going to work. I mean, I think it's a bold, interesting proposal. I think there's a bunch of problems with it. One is that I don't think the axioms, the alleged axioms that IIT offers are really all that axiomatic. I don't think they're self-evidently true. I think some of them might be true, but they're not, certainly not self-evidently true. And if they're true, I think their truth can't be established on the basis of introspection. I think further, it's not really clear that there are going to be any phenomenological axioms, i.e. claims about the structure of consciousness that are introspectively accessible and self-evidently true of all conscious systems. And even if there were, it's a further question, and I think a controversial issue, whether you could use those claims to constrain or really tightly constrain your theory of consciousness. I don't think, I suspect that even if there were a bunch of phenomenological axioms, they would be consistent with a bunch of different theories which would make different claims about different answers to the distribution question. So more to say here. I'm not going to say it here. I'm happy to talk about it in the discussion, but there's a paper there if you want to follow up that. So the bottom line is there is a response to this objection, which I think is most developed in IIT, but I don't think the response works. So that's the objection again, the cart before the horse. Nonetheless, I think the objection doesn't work. I think it's a little bit too quick, although I myself have been keen on it at times. I think part of the problem with it is it's assuming that there's a simple relationship between the cart and the horse, as it were, between theory and distribution, or counts of the distribution. Rather than the cart going before the horse or the horse before the cart. I think they need to, trundle down the road together, as it were. It's a terribly mixed metaphor, I realize, but stripping the metaphor out, I think theory, development, measurement really go hand in hand. This is not a novel insight, I realize. If you've got a domain, your conception of the relevant data, the distribution of the property, is going to be revised on the basis of an improved theory of the phenomenon, and that in turn leads to theory revision, which in turn leads to reconceptualization of the data, and so on. So Hassuk Chang, in his really interesting book about the development of thermometers and the history of how we figured out how to measure temperature, talks about epistemic iteration, where you go back and forth between the phenomenon and your theory of it. And I think that should at least be on the table here. So I think there are worries about a theory first approach here, but I think it's far too quick to say first we need the distribution and then a theory. I think theoretical developments will certainly help us with the distribution of the phenomenon. Second problem is it's not always clear what if you've got a theory in hand, what it instructs with respect to the emergence of consciousness. So here's I want to make this point with respect to another of the leading theories of consciousness, the global workspace theory. So as many of you will know, global workspace theory holds that the central mechanisms of consciousness are involve this global workspace that's implemented in frontal and parietal regions of the brain, and information becomes conscious when it's ignited. It's processed in local perceptual sensory processes, typically in the back of the brain. It gets ignited and distributed in this global workspace. So maybe a more revealing representation of the global workspace. You've got these input systems, a global workspace that allows the information to be globally distributed, and then that information gets used by various types of consuming systems. But I think it's clear if you look here that you could have lots of workspaces that are global-ish. You could have a system, a non-human system, non-human animal, or a human infant that has aspects of the global workspace, some aspects, but not others. At very early stages of development, infants won't have as many consuming systems as we do. They won't have the complexity of the consuming systems, won't have the complexity of the adult brain. So at what point do we say, oh, it's a global workspace as opposed to a global-ish workspace? What the global workspace theory needs to do is say, here are the critical parameters. Is the point at which a workspace has become a global workspace in the sense of consciousness generating. And as yet, I don't think there's been any attempt on the part of the advocates of this theory to do that. There's certainly no attempt to do that in any kind of principled way. So even if you were to start with a theory, it would often be very difficult to know how to apply it in these kind of cases. The third problem is maybe the most obvious problem. There are lots of theories. Which one do you choose? So here's a list from a recent review paper that Anil Seth and I published. This is 20 theories, I think. These are all neurobiological theories. I'm not going to go through it, but these are all taken seriously. And here's the theories that the paper I mentioned earlier, based on the attendees of the ASSC, looked at. And so they just asked people to comment on how plausible they found 10 theories. And you can see here, there's no real consensus. I mean, lots of these theories have people taking them seriously, but most of them have as many people saying definitely not or probably not to these theories. So there's a superabundance of theories, and worse, if so far as you can figure out the historical trend, it seems to be towards proliferation rather than convergence, certainly recently. So the lack of the diversity of theories, I think, wouldn't be so bad if there was a lot of convergence on the central mechanisms of consciousness amongst them. But on my reading, there isn't a huge amount of convergence. And we don't even have consensus as to whether consciousness is an exclusively cortical phenomenon. I mean, most of the major theories, the most influential theories, the ones that get the most press coverage, are exclusively cortical, but there's others that are taken very seriously by serious people that aren't exclusively cortical. So, it's very hard on purely theoretical grounds at the moment to make claims about, consciousness doesn't emerge earlier than such and such a time. Okay, I'm not going to dismiss theory-based approaches entirely. I think they're going to be useful, and they're certainly already useful in sort of heuristic terms in directing our attention towards certain phenomena. But I think they're going to be grounds for making strongly warranted claims about consciousness only when we have fairly well detailed theories about which there's reasonable consensus in the community. So in the meantime, I think to make progress, I would urge another approach, which in other work I've called the natural kind approach. So here's the basic idea behind the natural kind approach to addressing the distribution question. The guiding idea is that you treat consciousness like what philosophers call natural kinds: gold, water, hepatitis. I think it's a very familiar idea in sciences, certainly the biological sciences, that you think of the phenomenon as an underlying, having a real nature that underlies a bunch of pre-theoretical phenomenon, and you're trying to lock on to its real nature. So you've got real natures and not just nominal or, as it were, stipulated natures. And what you do is you look for nomological, those law-like clusters, strong relations of association between putative marks of the phenomenon. So when it comes to hepatitis, the study of hepatitis, you start off with a bunch of pre-theoretical features of hepatitis, jaundice, raised temperature, and all of that. And then you look for the underlying phenomenon, various types of viruses that explain and that, as it were, regulate and act as the mechanistic basis of those phenomena. And once you've identified those mechanisms, you've got grounds for revising, correcting, supplementing your pre-theoretical markers. Some of them, pre-theoretical markers, will turn out to be less sensitive or less specific to the phenomenon in question. Others will turn out to be really good and will be retained as part of a suite of markers or indicators of the phenomenon. So that's the basic idea behind the natural kind approach. I think, in a sense, it's what the science of consciousness does. It's not, as it were, an alien methodology for the science of consciousness, but it's not, as it were, the self-conscious methodology of the science of consciousness. When consciousness scientists or philosophers talk about what they do, they don't reach for this kind of language. They don't think to themselves as doing this, but I think that is, in effect, generally speaking, what people actually do. So one practical ramification of thinking about consciousness in natural kind terms is you don't want to begin with definitions or axioms. So if I had $1 for every paper on the distribution problem where people said, oh, well, we can't talk about the distribution of consciousness until we define consciousness, I'd be a fairly wealthy person. And you don't reach immediately for talk of gold standards or benchmarking or something like that. There's a place for those terms, but those concepts, those constructs, I think, need to be handled very, very carefully within a natural kind framework. Now, this slide is something of an aside. I just want to note there's lots of reasons to be suspicious of the natural kind approaches. It's come in for significant amount of criticism. So some people worry, Liz Irvine has been pushing this idea for a while, that actually consciousness isn't a natural kind. It's not going to turn out to be a natural kind. There's good reason to doubt whether there's a kind of a single unified phenomenon there. Peter Carruthers has been arguing you can't study consciousness through this kind of lens because the concept of consciousness isn't a natural kind concept. And there's an implicit assumption in that criticism that you could study something as a natural kind only if the guiding concept of it was a natural kind concept. So that's an interesting line of criticism. Ian Phillips has argued you can't really get the natural kind approach up and running because there's insufficient agreement of the pre-theoretical markers. So in the case of hepatitis, there's general agreement about the pre-theoretical marks or indicators of what it is to have hepatitis, but there's nothing similar, he argues, in the case of consciousness. So it's not as though there's a principled objection to it, but in practice, it's just not going to deliver anything. And there are other objections. I'm not going to dwell on those objections here. I'm going to assume that they can be reasonably answered. One of the papers I sent through to Jeff is this paper I wrote with Nick Shea a while back, which tried to engage with some of these objections. So I'm happy to discuss that in the Q&A. I'm just going to move on and assume that there's that it's reasonable to take a natural kind approach to the question of infant consciousness. All right. So with that thought, the next question is, well, what would a natural kind approach deliver with respect to infant consciousness? Now, if I knew the answer to that, I would have written it up, but I don't. And in part, I think it's because we haven't really exploited, we haven't really pursued the natural kind approach sufficiently rigorously. We don't have anything for consciousness in the way that we have for things like gold or hepatitis or a bunch of other phenomena. It's very, very early stages. So we're just really not in a position. This is very much a methodological suggestion as opposed to we're not in a position to report what this methodology has delivered because it hasn't been pursued rigorously. What I want to do, excuse the pun, is to take some baby steps, just kind of thinking out loud as to what things might look like if one were to take a natural kind approach, and just get on the table some interesting data that I think might be relevant. Before I do that, I want to say something about the kind of data I'm going to focus on. I'm going to look at three sets of data, as it were, and it's all neural. I'm not going to say anything about behavioral data, and that's not because I'm against behavior. It's not because I think behavioral data's got nothing to teach us. I think it's got a huge amount to teach us. It's really just for two reasons. One is the case studies that I think are interesting just happen to be neural. But the other reason is there's this fascinating paper that came out a month or so back. I think it's just still in press in Trends in Cognitive Sciences, arguing that prior to 3 months and not really fully online till 6 months, cortical control is basically absent. So neonates basically have no cortical control of their movement. It's all subcortical. So eye movement, movement of limbs. That only starts to come online at 3 months and is really only properly in place 6 months and beyond. Now, I don't know if that claim is right. This is not in my wheelhouse, as they say. I'm no means an expert in this stuff. And this paper is straight out. I've talked to a few people who know something about it, and the consensus seems to be it's quite a provocation. I think we need to wait a couple of years, see what kind of pushback. So I'm not betting the farm. I'm not even betting on the front gate of the farm on this. But I think it's a really interesting claim, and if you put that together with a thought that's widespread, again, I'm not betting the farm on this thought either, but it's certainly widespread that consciousness is exclusively cortical, you get a really interesting result, which is that it doesn't really matter what neonates are looking at or how they're responding or what they find boring. That's not giving you evidence of consciousness. So I think it's too early to say how claim 1 is going to hold up, but I'm intrigued. And it's too early to say how claim 2 is going to hold up, I think. But if you're, in the 95% of folks who think consciousness is exclusively cortical, and if one holds up, then you've got reason to be a little bit skeptical about the use of behavior as a measure of consciousness in early infancy. So let me just throw that out there as a provocation, as it were. Okay, so I want to talk about three, as it were, brain-based approaches to the emergence of consciousness. One's, if you like, a marker of the capacity for consciousness, another's a putative marker of perceptual consciousness, and the other's more of a proposed source of data. So the marker of the capacity of consciousness involves the DMN, the default mode network, one of the brain's intrinsic connectivity networks, as they're called. I don't know that the DMN activity is required for consciousness. There's some evidence to suggest that in some conscious states, it's the DMN's not active, but it does look to be fairly strongly implicated in various states of consciousness, emergence of consciousness from sedation in anesthesia, and the emergence of consciousness following coma and a vegetative state or unresponsive wakefulness state. It looks like there's a pretty strong correlation between the reemergence of consciousness in those conditions and not simply DMN activation, but coupling between the DMN network and other networks, in particular the dorsal attentional network. And that's interesting from an infant point of view, because one of the things that's come out in the last couple of years is that the DMN's pretty active in early infancy, much more so than I think people realized or suspected a while back. It's present in newborns. Indeed, there's rudimentary DMN activity even and has been detected even in fetuses. I think that paper is a bit controversial, but that's out there. And not just DMN activity, but also kind of a reciprocal relationship. So this is works that's come out of Trinity College in Dublin, using a large set of neonates, that there's not just that you've got activity in the DMN, but there's reciprocal activity, there's communication between that and, for example, the dorsal attentional network that looks like it's very much implicated in consciousness in these other conditions, for example, disorders of consciousness. Now, there are things you could, worries, qualms you could raise about some of this work. One of the findings is that although it's there, it's weaker. There's weaker within network connectivity in infants. And it's possibly not till about 2 that you get adult levels of connectivity. So you might say, okay, it's there, but it's high levels of connectivity. That's what makes the difference for consciousness. These inferences are always tricky to draw. And so I think, no single piece of data, this is part of the point of the natural kind method. No single piece of data is going to do the business, but it's evidence. Evidence is defeasible. It's not demonstrative, but I think there's some interesting evidence here pointing towards the potential for consciousness fairly early in infancy. The second data point I guess I want to talk about is work that's done with what's called the P300, or sometimes called the P3B responses, cortical response to a novel or surprising stimulus. And what's particularly interesting is responses that involve what's called global oddballs. So let me explain what a global oddball is for those of you who aren't familiar. It's not someone who's known around the world as being an odd person. It's a second order oddball. So if you look at these stimuli here, so imagine that the green dots represent a low tone and the red dot represents a high tone, or vice versa. So you've got sets of 5 stimuli, sets of 5 sounds, where the 5th in every set is, let's say it's a high tone. So it's so the high tone there would be a local oddball. So suppose you're presented with these sequence of sounds. If the sequence ends in the top way, with the 80% of sequence ends, then the 5th tone is going to be a local deviant. So it's going to be a deviant relative to that set, but it's going to be a global standard. That's what you expect, because every other set has had a 5th tone being high. So if you've learned the relationship within sets, then what you'll expect is that the 5th member of this set, this final set, is also a high tone. Okay, global standard, but local deviant. But on some trials, if the 5th tone is a low tone, then it's a global deviant, because you're expecting that the final tone on every set is an oddball. So this is second order irregularity. And this was introduced, the use of second order or global oddballs was introduced as a measure of perceptual consciousness by Tristan Bekenstein in 2009 paper. So that's just highlighting the global oddball as evidence of consciousness in disorders of consciousness, because it looks like only individuals who are conscious and perhaps in a state of alert wakefulness, paying attention, as it were, to the stream of stimuli, will have a P300 cortical response to that oddball. So you can get local oddball responses in sleep, in vegetative state patients. It looks like the response to the local oddball is not an indicator of consciousness, but it looks like you need to be conscious, maybe even alert, to pick up on the global oddball. And with that in mind, Julia Moser at Tübingen looked at responses in infants to global oddballs, and she had 20 infants in her study, about a month old, and at least when the infant was in the state of arousal, which they measured in terms of high heart rate variability, there was a response, was reliably present. Even more interestingly, the same team used a fetal MEG system, where the coils are around the mother's abdomen, and are picking up brain signals from the fetus. And stimulus is slightly different from the one I showed you, but it's the same, basically looking at second order oddballs, looking at hierarchical learning. And a sample of 56 fetuses, and they were able to pick up using MEG, using this fetal MEG system, a global oddball response after about 35 weeks of gestation. Now, there's a lot of pushback, a lot of potential worries here. One which I think is worth remarking on, but perhaps not so serious. The latency in these perinatal contexts is a lot longer. So it's called a P300 or P300-like, but it's actually 700 milliseconds. It's a lot longer. Everything's longer in the infant and fetal brain. And more importantly, I think it's not at all clear how specific to consciousness the global effect is. So it's generally recognized it's not highly sensitive, so you can be conscious without, as it were, having a P300 or P300-like response to global oddball. There's been some suggestions in the recent literature that you can get this global oddball response in coma patients, anesthetized patients. There's been pushback. I think the dust hasn't settled on this debate. So again, I'm not going to bet the farm that this is an indicator of perceptual awareness, but it's an interesting data point. And even if it's not a completely, as it were, 100% specific to consciousness, you might think it's evidence raising. It moves the credences. Okay, so that means I've talked about two sort of sets of data which I think are relevant. Let me briefly mention the proposed method. So this builds on work done by Marcello Massimini in Milan, and a couple of papers there that are fascinating papers, where he's introduced what's called the zip and zap approach to measuring consciousness. So what you do here is you zap the subject's brain with TMS, and then with EEG, you measure the cortical response. That's the zip bit. So basically, you're looking for complexity of the brain's response. You want to see whether there's a widespread response and whether the widespread response is complex, or whether it's a simple response. And the response there is computed in terms of what they call a perturbational complexity index. So this is a complicated picture, but I'll talk you through the main bits here. So there's different TMS targets. That's the shapes of the symbols. On the left hand, there's a PCI response. That's the perturbational complexity index from 0 to 1, where they've compressed it down to a number between 0 and 1. And they've got 8 subjects, normal state of normal alert wakefulness, and they've compared it to those subjects in either non-REM sleep or under the influence of 3 different types of anesthetics. And you can see there's a lovely separation between 2 types of PCI responses, right? If you're awake, if you're state of alert wakefulness, relatively irrespective of the TMS intensity, you get a PCI response of about 0.5, 0.6. If you're either in non-REM sleep or fully sedated, you do get a PCI response, but it's way lower. And there's a nice separation into 2 data groups. So they use that as a kind of a benchmark. And then they, this is the really fascinating bit, they compared that to a bunch of patients suffering from various types of brain injury. So locked-ins, had 2 locked-in syndrome patients, fully conscious, that's what you'd expect, and they had a PCI response comparable to neurotypicals. Emerged from minimally conscious, which is understood to be conscious, but still suffering from some problems in cognition and behavioral control. Lower PCI, but again, within the broader, within hailing distance of the range that you get in normal wakefulness. And then tailing off as you go from minimally conscious to vegetative state patients who look much more like non-REM sleep patients or anesthetized patients. So if you're thinking in terms of correlations with our pre-theoretical measures of consciousness, remember I introduced that idea 25 minutes ago, you get a nice correlation here. Does that validate the PCI as a measure of consciousness? Does that give us grounds for thinking it might override a pre-theoretical measure? Suppose we had a vegetative state patient that turned out to have a very high PCI response, comparable to a normal neurotypical person in a state of wakefulness. Maybe not, but it's at least interesting, I think, that there's a strong correlation here with clinical measures. I think one would want to do more by way of validation to put enough trust in the PCI response as a real test of consciousness, but it's certainly on the road, I think, to that. So you can't do the PCI on babies, even your own babies, but perhaps a sensory perturbation or complexity index might work. So this is a suggestion that has been developed by Joel Froelich in Tübingen with some other folks who have worked on the MEG stuff that I talked about before, including Julia Moser. And the idea here is you could use auditory stimuli, sounds, you could do lights, or you could even do smells. You could do a kind of a sniff and zip. And by different sensory modalities, you could think of those as it were sensory perturbations rather than the kind of perturbation, the electromagnetic perturbation that you might get from TMS. Now, obviously, this hasn't really, the framework's not here in adults, hasn't been validated in adults, and it hasn't yet been done in infants or fetuses. But it's an idea that's out there of trying to extend the kind of work that Massimini has done with the zap and zip and develop more ecologically sensitive ways of trying to get at the emergence of consciousness in ontogeny. Okay, few more slides and then I'll finish up. How far does this kind of work take us to an execution of the natural kind approach? It takes us some of the way, but not perhaps particularly far. At best, what it shows is that if you take a measure that looks like it's correlated with consciousness in adults, you can see when it applies to infants. That's great. But the key bit to the natural kind approach is to look at the relations between those measures and what we know about the mechanisms that underpin them. And that's the bit that we don't yet have. That's the bit that we don't have our heads around. That's the bit that we're not in a position to execute. Okay. So far, this is, as it were, as I think of it, sort of part one of a natural kind approach. Part two would be this integrative procedure that is still too early to do. Okay, so that's the emergence talk. Jeff, I can stop here or I can talk for another 8.5 minutes. Up to you.
I think you should go for it.
Okay.
I vote for the 8. Yeah.
I'll try and keep it to that. Okay, so I've talked. Sorry, where am I? So I've talked about the emergence question. I mean, I haven't answered it. I've talked more about methodology, but I've focused on that. Let me just say something as a kind of a postscript about the character question. What is it? What might the earliest forms of consciousness be like? And I'll just give you two little snapshots of data that might be the kinds of things that would inform answers to this question. I think there's two ways into this character question. One is to focus on content. What kinds of contents might characterize the earliest forms of experience? So if you think of contents in terms of properties, objects, events, what might a 1 day old, a 1 week old, or 1 month old infant be able to perceptually track, consciously track? Another, which is in a way is more interesting, is the structural features of early experience. So I'll say something about each of these ideas. there's a fascinating literature on perceptual, what's called perceptual narrowing or perceptual attenuation, which is basically the idea, as I understand it, that infants lose the capacity to distinguish perceptual categories that aren't really relevant to them in their environment. So the earliest work here was done on phoneme recognition in young infants. So this comes out of Janet Worker's lab, work that started in the 80s, that very young infants, I think they first looked at 6 to 10-month-olds, but I think there's data from even younger, seem, and this is qualification because this is looking times and all of that, seem to be able to distinguish phonemes that aren't used in their native language. So they were studying English-speaking adults, children raised in English-speaking homes that seem to be responsive to consonants that are distinguished in Hindi, but English adults really have trouble hearing the distinction. They basically can't hear the distinction between the consonants. Infants seem to be responsive to it. As they got older, they seem to not be able to track the difference, in part because those differences, those phonetic differences, weren't marked. And there's been a whole slew of work here showing that this applies not just to consonants, but to vowels and even tonal languages. Very young infants are sensitive to a whole bunch of tonal discriminations, but if you grow up speaking a language that's not tonal, you'll lose that very, very early on. And so that's within language. Face discrimination, face perception looks like something comparable happens. So at 3 months, infants seem to be really as good at distinguishing between other race faces, as it's put, then equally competent with other race faces as with faces belonging to their own ethnic group. But by 9 months, that distinction seems to have dropped off if they're not surrounded by the members of other ethnic group. You don't need that discrimination, so you lose that capacity. It's sort of like the way I think of it is the converse of kind of perceptual learning. Well, it's a perceptual learning which involves attenuation rather than the exploitation or the development of new categories. It's the loss of old categories. So that's one way to get at one interesting data point on contents. In terms of structure, here's a data point that I think is interesting, thinking about what the structure of infant consciousness might be like. So the attentional blink's a well-known, well-studied phenomenon where if you've got a rapid serial presentation of visual stimuli and you're aware of the first, the second of the two visual targets goes undetected because attention gets captured by the first target, and it's a couple of 100 milliseconds before that capture goes and you're consciously perceive the second target. And a really interesting study that came out with Hockman and Sudquidea looked at the length of the attentional blink in young infants, and it's kind of amazing what they found that so in adults, the length of the attentional blink, the adults are on the right here, it's roughly about 200 milliseconds. So if the second
seemed to have frozen up a little, very long attentional blink.
Yeah. Okay. So anyway, the attentional blink's much longer, which suggests the temporal structure of infant consciousness is very, very different. Even if, I mean, one way to synthesize the two findings is, even if in certain domains, infants are aware of a whole lot more than, or the young infants are aware of a whole lot more than older infants, the awareness is squeezed into this bottleneck that has a much, much slower refresh rate. There's much, the capacity within any 1 second window is much reduced.
Could I interrupt you real quick?
Yep.
Would you be willing to share your slides again?
Sorry. Yep. Okay. So those two snapshots on, the characterization, what is it like to be an infant? So how far have we come? Well, we're a long way, obviously a long way towards answering my titular question. What is it? When does consciousness emerge? I think we're making a little bit of progress. The methodological issues are obviously incredibly difficult. But here's an interesting thought just to finish you with. There's a sense in which, because infants presumably aren't self-conscious and don't have much in the way of introspective access, maybe we're heading towards a time when we kind of know more about what it's like to be an infant than infants themselves do. So anyway, I'll end on that thought, and thank you, various collaborators, and thanks to you for your attention and forbearance with the network problem.